This is a short sample from Professional Learning for Maths Unit 4, Applied Mathematics. I've chosen to look at probability and differential equations, forming and solving them. There's a couple of issues that we need to consider. So, WJEC give us all the trusty formula for probability that we need. Using and applying them, it tends to be more difficult. So, the formula booklet gives us the whole raft of these, and rarely, if ever, do you need the Bayes theorem. You'll see how I get around that particular little beast in a few seconds' time, a few minutes' time to be more precise. But there is a question as to whether simple Venn diagrams give our learners a better visual method for solving such complex problems. The link at the bottom is to quite a nice GeoGebra app which develops mathematical understanding of areas within Venn diagrams by getting you to click on certain bits, and it's worth passing on to students to work on. So I've chosen to use a question from 2018 Unit 4. As it happens, it's question 1. Welcome to the exam, guys. So I'm assuming you can read. First couple of marks. For only 2 marks, we don't do hard work. So the former method, the probability that he doesn't win, clearly 1 minus the probability he does, because it's a mutually exclusive system. Either he wins or he doesn't. And the probability that he wins is the probability that he wins A, or that he wins B, hence there's an addition, minus the intersection of the two, because otherwise you're double counting. So hence we get the 0.6 plus 0.5, clearly that would give us 1.1, which isn't going to work, minus 0.2, which gives me the 0.9 that I need. So the probability he doesn't win is 1 minus that, 0.1. In a Venn diagram, the approach is relatively simple. Apologies, I can't get a decent Venn diagram to go into PowerPoint. I can actually draw circles in there or ovals in there, but I can't get them to overlap per se. So clearly, when you're drawing the Venn diagram, the fact that the overlap between the two is the 0.2, hence, seeing as the probability of winning A is 0.6, it only leaves 0.4 in the main part. Probability of winning B is 0.5, so it only leaves 0.3 in the main part there. Just looking at that, you can see that the total probability of winning is 0.4 plus 0.2 plus 0.3, 0.9, and seeing as the sample space has got to be equal to 1, the probability he doesn't win is the bit outside that shape, 0.1, because that's all there is available. Probability that he wins exactly 1 bit. Now in this particular case is he either wins only A or only B, and therefore we've got to get rid of that intersection twice, so therefore we end up with a 0.7. If I go to my Venn diagram, which is just a copy of the one I had before with a little bit of highlighting on it, then you can clearly see my two highlights are 0.4 plus 0.3, hence my 0.7. 2 marks. That diagram does it for me. And given that he does not win bid A, find the probability he wins B, bid B. 3 marks. So I've got 7 marks in total on this question, and I've done all of them using a picture. So going back to my Venn diagram, he can't use 0.4 and 0.2 because those are involved in winning A. The probability he wins B, but not A, is just the 0.3 that's inside B, and the only available probabilities if you take out the not A is the 0.4, the 0.3 and the 0.1. So the probability B given A dashed is going to be 0.3 over 0.4, and I would always treat that as 3/4. The diagram makes the difference. Now, forming and solving first order differential equations. We're about to embark on one of my real bugbears here. If you've heard it before, I apologise profusely, but you will hear me do it again and again and again, and one day perhaps we'll get it sorted. So prior knowledge that one point I should work out here is I'm not using XUVAT, which is what physicists use. We use SUVAT in mathematics because S is the Latin for distance, and if you're using XUVAT, it does rather suggest that all motion is in the X direction, which we clearly know in mathematics is not true. So hence we are using SUVAT, and we don't rarely, or in this particular question, we're not using the SUVAT equations, but it's useful to know that velocity, or remember that velocity is the rate of change of distance with respect to time. The acceleration is the rate of change of velocity with respect to time, and hence it's also the second differential of distance with respect to time. However, that's just for the sake of completeness, because we're dealing with first order differential equations. You are not going to meet on a Unit 4 question anything that's got d2s's dt squared. Those will require an auxiliary equation method, which are to be found in further mathematics. So this is a WJEC question again, so fairly typical question. I'm not going to insult your intelligence by reading it out. The important things are the mass, the initial speed, the fact that there's a resistance and what it's proportional to, and the fact that I'm given a velocity and a value for the resistance. That's to enable me to find the constant. So I've got to show that the upward motion of the object satisfies a differential equation. Now, you'll understand from the way that's written that it actually gives you the differential equation. I haven't done that in this particular case. I will pop it in at the end just to show you that I've got the same. But they do like these questions where they show you, they tell you what differential equation you have to find, because obviously if you don't find the differential equation, you can't solve it. So one thing with all applied questions, by and large, draw a diagram. DAD, draw a diagram. I apologise for my artistic skills. Always show a positive sense. In this case, seeing as it's being thrown upwards, the positive sense would be up, but it doesn't really make any difference. If you want to go downwards, that's fine, because two of your forces, that's the force due to gravity and the resistance, are acting downwards, therefore it would make sense to use that as the downward sense, but I've chosen to go upwards, seeing as that's the usual positive sense. But simple diagram, I've shown all the forces that are applying to that system. I know that R is proportional to kV, hence R is proportional to V, hence R equals kV. Using my values, K is 0.4, so I've got that R equals 0.4 V. And now I can go into my trusty Newton's second law, force equals mass times acceleration. Forces acting downwards, which are in a negative sense, minus G over 2 minus R, equals my 0.5, which is my mass, times the acceleration, which is what I've got to find in this particular case. So minus 0.5 G minus R equals 0.5 A, but A is equal to dV by dt. I want a differential equation. So replacing my R by my 0.5 V, which I found before, and dividing through by 0.5, no real problem, I'll get that dV by dt is equal to minus G minus 0.8 V. Halving everything, isn't it? Or doubling everything, my apologies. And here comes the proper answer, that dV by dt equals minus 9.8. G, of course, is 9.8 in mathematics. Might be 9.81 in physics, but it's 9.8 in mathematics because it's nice. Okay, minus 0.8 V. So I've got that. I've chosen to use G because I simply would choose to write it. 3 marks for this question. Finds an expression for v in terms of time t. 6 marks. So I've got a 9-mark question going on here, which is really quite a lot of marks on this paper. And you've got to be able to solve that differential equation that you've just found. It is a variable separable, and you do separate the variables, but I have a bugbear about separating the dv by dt. It's not right. So bear with me. I'll explain what I'm doing. dv by dt equals the thing I found before. Notice I'm writing g instead of 9.8. I've extracted the minus sign out of that. I don't have to do it. I can actually leave it in there, but it suits me to do so. And as is common, it's not unusual with questions like this to have a common factor to take out. And as is usual, you have to rearrange the sides. Now it would make sense, seeing as I want an equation for v in terms of t, to move my functions in v. And remember that g plus 0.8v is a function in v, g is a constant. To move that onto the left-hand side, because that's where we normally find our subject. And that would only leave me minus 1g. So I divide both sides by g plus 0.8v, and I'll get 1 over g plus 0.8v dv by dt equals minus 1. Now this is where I would vary from WJC, and in fact from a number of my colleagues, because what they would do there is split up the dv by dt and get 1 over g plus 0.8v with respect to v is equal to minus 1 with respect to t. And you're then asking students to do something different on each side of the equal sign, and we've banged into them for years and years and years that you can do anything you like to an equation as long as you do the same thing on both sides. So hence I would leave the dv by dt. Now I would integrate both sides with respect to t. And that's what's really happening, because the integral of 1 over g plus 0.8v dv by dt is the reverse of an implicit differentiation. And that's perfectly reasonable. It's a classic log function, as happens in most differential equations. So now, of course, the differential of g plus 0.8v is simply 0.8. Now I haven't got that. I've got 1 in there. So therefore, there is a factor of 1 divided by 0.8 out the front. And seeing as I'm old, 0.8 is 4/5. 1 divided by 4/5, 5 over 4. ln g plus 0.8v, and you notice I'm using moduli signs here. If your students use brackets, don't get uptight about it. The main reason for that is that g plus 0.8v could, if v was negative, actually, apologies for the ringing bell in the background, the phone goes at the most inopportune moments. If g was sufficiently large and negative, or v was sufficiently large and negative, it could make that a negative, and logs are not defined for negative values. Okay, but the integral of minus 1 with respect to t, or the integral, I could even put the minus outside, and the integral of 1 with respect to t would be minus t plus some constant. Remembering my constant of integration is always a useful thing because it will cost you marks. And given that v equals 24 initially when t equals 0, I can see straight away that c is going to be 5 over 4 ln 29, because 0.8 times 24 plus 9.8 will give me that 29 that I need. So I've now got that minus t equals 5 over 4 ln g plus 0.8v minus log 29. Log laws, log minus log is a division. And again, I'm using strict moduli because it could be considered to be negative if v was taking the wrong thing. And I've flicked that I've multiplied both sides by 4/5 just to bring that out, because I want to raise things to the base e in order to get rid of the logs. So taking inverse logs on both sides, anti-logs if you like. 29e to the, and I've gone to write 0.8 now because it really makes a horrible mess if I try writing 4/5 t there. Is equal to g plus 0.8v, and therefore v equals 5/4 bracket 29e to the minus 0.8t minus g, and that's my 6 marks. But the main difference is that I personally treat that as an implicit integration, or the reverse of an implicit differentiation, OEF incidentally, or equivalent form. You could multiply through by the 5/4, but I think that's quite an elegant answer. So variation on this method is, if I start from the same point where I'd separated my variables 1/g plus 0.8v with dv by dt equals -1. So I've got my v's on the left hand side and my other terms, in this case there are no other terms, on my right. Then what I can do is I can actually integrate between a general limit. So because I'm integrating on the left hand side v implicitly, my upper limit is going to be v. My initial condition when t equals 0 is v equals 24, hence the 24 at the bottom. And on the right hand side, general, because it's with respect to time, is t and 0. So I can actually put that in, and I've had to go on into handwriting now because PowerPoint won't allow me to put in superscripts and subscripts on square brackets. So my integral of 1/g plus 0.8v is 5/4 ln g plus 0.8v between the limits v and 24 equals minus t. Notice I've taken the minus out this time, between the limits t and 0. And what it does is it stops me having to evaluate the constant of integration, so therefore I don't need to, if I've forgotten to put it in, it doesn't matter because I don't need it in this case. And it also gives me the equation without me having to remember to put it back on again. So using my limits with v equals v, I'll get 5/4 ln g plus 0.8v minus 5/4 ln g plus 0.8 times 24. That will give me 5/4 ln 29, log minus log, takes me back to the same place. On the right hand side I've got minus t minus 0, which of course is just negative t. Hence I'll get 5/4 ln g plus 0.8v over 29. Stricter moduli, because of the fact that v could be negative and we don't want it to be, equals minus t, and from then on it goes on. So it's a slightly different way of doing it.